Hi. Okay, so as I mentioned in the previous video, I've been doing a lot of flight testing and building models, and this is a traditional piece of innovation, so to speak. It's two existing technologies that are married into one. So it's a Tricopter Glider, and it turned out to be a 6-kilo monster with 12 motors. I think it has a wingspan of almost 5 meters. It's a 1:4 scale model, by the way, and it has a kind of unique wing structure, but it's not very beneficial, so I won't go into that. Here I'm testing it out in the tricopter mode, and sometimes I just have to go this far to discover what the actual difficulties are. And it's well, except for this being a very high cost and overweight glider, it's actually more about how to flight test vehicles when you start scaling them up. So even in this 1:4 scale version, it's difficult to find a good location to actually do the transition between hovering mode and glider mode or power glider, and to do this in a manned version would just be it's out of the range for a DIY project, unfortunately. So I really just have to drop this idea and try to be more creative, actually. So I was thinking about a more childish approach to flight. They say that a propeller is just a pair of spinning wings, but what if you did spin a pair of airplanes instead of just wings? What would be the benefit of that, you might ask, but I think it has some credits. So in a traditional helicopter, you have to have a stiff mechanical coupling between the rotating wings and the hub. So you're sort of limited in how far out the lifting surfaces can be. But if you spun airplanes, a couple or perhaps many, you could control them individually and have a kind of loose connection to the center. So like Kevlar line or a wire or something. And the point of that is that you can spin them at a pretty far distance out, and sweeping a lot of air is much more efficient than sweeping a small column of air and accelerate it very forcefully. So, and this is a kind of small version of that. It's the airplanes are still quite tight to the center, but if you control them with say a flight controller, you could have them placed very far out and still have control over their angle of attack and such. In this setup, I think I managed to make them produce around 1 kilo thrust or so. It wasn't super efficient, but it wasn't too bad either. And in this slow-mo clip here, you can see the shortcoming of this concept as is right now. It's just so easy for the spinning planes to enter some sort of oscillating state, and it just gets worse and worse and totally out of control. But I think the concept has merits. It could potentially be very efficient, spinning like gliders far out. And if you have individual control of the elevator surfaces on these flying planes, it could potentially work, I think. So I just had to give it a more serious try, with the least amount of effort this time, I should say. So it's just a single flying wing on a string, and I started out with having a bottle of water as a counterweight on the other side. That turned out to be a horrible idea, so that's just for the very first test, and after that I'm trying it out without a counterweight and letting the whole setup here wiggle back and forth instead. Okay, here you can see the wing itself. It has the battery in one end, the motor in the other, with a flight controller hidden there underneath the plywood. The center of gravity is span-wise in the middle, on the spar there. And you can see the control surfaces. It weighs around 1,240 grams. Here you can see the flight controller do its stuff. It's only sensitive to pitch. Yeah, okay, so here I'm just doing the very first trying out and thinking, and yeah. So here I'm tying the counterweight bottle to the rotating arm up there. Yeah, and this is sort of depressing. You know, it's the first time you know it's going to fail. It's just a matter of, you know, how much, and it turned out to be quite significant. So I'm doing this. Yeah, I mean, this sort of exercise is why I got this playground out in the forest. I really want to be alone. I feel like a jackass just by myself. You know, if somebody would be watching me, it would just, it would just be so depressing. Okay, because you know you have to have your maximum analytical ability turned on, and no matter how kind people are, it's just it's just like aggravating to have, you know, someone just standing by, even, you know, smiling and wanting your very best, you know. Okay, so yeah, it works completely horrible. I'm just trying to figure out how to start it, and I'm trying to figure out what settings I need, and I'm just thinking, you know, is this actually worthwhile? Stuff like that. Well, okay, yeah. It doesn't fly, but it sort of spins anyway. So this is the you know, the birth process. It's pretty painful. Yeah, but it's getting better. Yeah, as you can see, I've cut the counterweight there because it just messed the dynamics up even more. So it really, you know, either you should have a symmetrical load, exactly symmetrical load, you know, another flying wing, or nothing at all. And this is the first low effort test, so I'm going with nothing at all. There are things to say here. So I'm running a KK 2.0 flight controller. It's a, you know, Hobby King's budget version. You have a small LCD screen coupled to that via a cable, so you can tune the PIDs with that, and that's very helpful. And I can also, you know, turn off the roll and yaw stability, and it has a self level, which is turned turned on, of course, because I want the wing to level out and fly circles around the pole. Oh, which it's doing right now. That's good. You can hear the servos working hard, or the flight controller working hard through the servos. After a couple of crashes, the motor gets quite unbalanced, and it really does mess up the sensors of the flight controller. So as soon as I turn off the motor and let the wing glide, it stabilizes much quicker. So I'm trying out different settings here, and it's quite interesting. It's getting more and more, you know, what do you call it, rewarding the further the test goes. Oh yeah, here's a slow-mo clip as well. You can actually hear the servos working. You might wonder about the G-forces. Well, I have been, you know, doing some basic calculations, and yeah, it goes quite well. And in the, you know, full size version, you know, perhaps 200 kilos capable of lifting 200 kilos, it would be like 5 or 6 Gs. So it's really low. The RPM would be ridiculously low. It would be like 22 RPM or something. Okay, so I'm just for my own memory's sake here recording the settings of the KK controller. Not that I will be flying this exact wing again, but it's good to have a well, I want to know what settings I had when it flew the best it could this day in this setup. Here I'm trying it out without the flight controller, so I'm just manually steering the control surfaces, and thankfully it turned out to be super difficult, and so the flight controller really did a lot of good work making this fly in circles. So this is this is me piloting the wing, and it's really difficult. So I was kind of pleased to see how I mean, this revealed how well the flight controller actually manage to control this wing, and this wing is just a random bit of non-engineering, so I don't know if I got the correct control surface areas or nothing, but still it did a pretty good job at spinning the wing and keeping it you know, in a nice flat circle. You wouldn't want to be aboard that flight. Okay, yeah. Interesting. So, what's my conclusion? Yeah, that was not very promising, but it was interesting enough for me to give it a second go with the new design. Hopefully I will be able to explore this new design in a couple of days, and I will see you in the next one. Bye!